All right, so let's get down to calculating some derivatives. So if I'm given the function x cubed plus 2x, and I'm asked to calculate the derivative. So the derivative then would be the f prime of x. By the way, there are other ways to write derivative. There's the derivative can be the f prime of x. It can be written as dy dx. Sometimes it's written as y prime. There are some other notations that are kind of ancient, and they'll show up every once in a while, but it's just the derivative notation, just various derivative notations. So I'm going to color code this to make it easier. The derivative of this function then is the limit as delta x values approach 0, so as the difference between the 2 points approach 0, of f of x plus delta x minus the f of x all over delta x. All right, so now I just want to plug it together using this function. So first I'm going to rewrite the f of x plus delta x. So I get the, well, let me start with the limit. Yes, you have to write it every single time. So the function where I plug in x plus delta x is x plus delta x cubed plus 2 times x plus delta x minus the f of x, x cubed plus 2x. So first I want to find x plus delta x cubed, and I could certainly put it in my calculator, but this is a good opportunity to review the Pascal triangle method. This is my favorite method of doing it rather than memorizing. So this is the row I want to use for my x cubed, and this would be a cubed plus, and we have a plus sign so we don't have to worry about negatives, a cubed plus 3 times a squared b plus 3 times a to the first power b squared plus 1 time b cubed. So now if I put it all together with my a's and b's here, I should be able to write this out pretty quickly. So let's see, that would be the limit as delta x approaches 0. And I'll do this part in green. So I have x cubed plus 3 times x squared times delta x plus 3 times x delta x squared plus 1 times delta x cubed. That was pretty easy enough. Plus 2 times x plus 2 times delta x. Okay, minus x cubed. Oh, we have to be careful. I put in minus x cubed plus 2x, but without parentheses, I might accidentally not change the sign. So be careful. Put parentheses in when you do that, and definitely think to double check when you're doing this second part of the function. X cubed minus 2x. And as long as I'm talking about being safe and careful, it's really kind of a smart idea to put these in parentheses whenever they have a power on them. Okay, now this looks like a big ugly mess, but really it works out in your favor. If I take all my delta x terms and group them together, I can factor out a delta x. But I'm getting a little ahead of myself. Let me combine like terms first. So the limit as the change in x approaches 0. So let's see. I have x cubed minus x cubed. Oh, look, those cancel. That worked. And then, by the way, this is going to happen a lot. And then I have a plus 2x and a minus 2x. That was easy enough. And now I'm just going to rewrite all of this. 3x squared delta x, I'll use parens this time, plus 3x delta x squared plus delta x cubed plus 2 delta x. All over delta x. Now, the shortcut here would be to cancel the denominator with one of the delta x's all the way through, but in the beginning, please try to avoid doing that for a number of reasons, but particularly because it's easy to make mistakes. So I'm going to factor out 1 delta x, and that leaves me with a 3x squared plus 3x, I still have a delta x there, plus delta x cubed, I still have 2 delta x's there, plus 2. Now I can cancel my delta x with my delta x in the denominator. I still have delta x's, but I don't care if they turn to 0 in the numerator, so I'm really kind of done. So now I'm going to substitute my zeros in. I get 3x squared plus 3x times 0, that disappears. Delta x squared is 0 squared, that disappears, plus 2. And that, my friends, is the derivative. This is the f prime of x. So you're going to get a function out as the f prime of x. Let's look for a second at what that means. That means that if I have a curve like this, and I calculate the slope of the derivative, I want to know what the slope of that line is, I can calculate it, but then if I later want to know what the slope of this line is, I can certainly calculate that. And then if I later want to know, like I could calculate all the different tangent lines, or once I have the derivative, all I have to do is plug in my x value. The slope of this tangent line is whatever this x is plugged into there. So the slope of the line that's tangent to the graph at -3 would just be, or I guess I should say the f prime of -3 would just be -3 squared is 9 times 3 is 27 plus 2. The slope of this line is just 29. Look how fast that was. How cool was that? Now how about here? What if this is the f of 2? Well, the first derivative, or excuse me, x equals 2. The first derivative of 2, or the derivative at 2, the slope of the line that's tangent to the graph at 2, would just be 2 squared is 4 times 3 is 12 plus 2 is 14. Done. What if I want to know what the slope is at 182? That would just be the f prime of 182 equals, fortunately I don't really care what that is, so I'm not going to do it. All right, let's do another example. So let's differentiate the f of x, that means find the derivative of, by the way, 1 over x. So we want to find the derivative, f prime of x equals the limit as the change in x approaches 0 of f of x, let's color code again, f of x plus delta x minus the f of x all over delta x. Now let's plug it in. The limit as the change in x approaches 0 of 1 over x plus delta x minus 1 over x all over delta x. So all I did was plug x plus delta x into this function, and then I just wrote the function down for the second one. There's no way to get around this. I'm going to have to find a common denominator. It's a relatively easy one, so I'm not too worried about it, but sometimes it just must be done. So x minus x plus delta x over, multiply the denominator, x times x plus delta x all over delta x. So I'm going to go sideways just to save room. The limit as x values approach, delta x approaches 0 of my numerator, well, let's look. My numerator is just x minus x, so the x's cancel. So negative delta x over the denominator times the reciprocal of the overall denominator, which just means I'm going to have a delta x here. These delta x's cancel, and so I have the limit as delta x values approach 0 of minus 1 over, well, check this out, x squared plus delta x. Now I can go ahead and plug in my 0. I don't mind having a 0 for delta x now because I have an x squared, and x squared in the denominator isn't a problem at all. So my derivative equals negative 1 over x squared. So if we had been asked to find the slope of the line tangent at some given point, let's choose a point on the original. Say I choose, say I choose 3 for x and 1/3 then for y, that would be the output. How would I find the derivative at that point on the graph? So we're actually looking at, we know what this graph looks like, right? So x equals 3, what would be the slope of the line tangent at x equals 3? At this point we don't really care about the y output because that's just a coordinate. So I would say that the f prime of 3 is negative 1 over 3 squared, so negative 1/9. So this line, the slope, would equal minus 1 over 9. It would rise 1 and run 9. Of course, either the rise or the run would be in the opposite direction because it's a negative.